This is the first of 3 demonstrations designed to help students understand the tristimulus theory of color perception. Whilst this theory forms the basis of color reproduction technology in photography, film, television and printing, it is by no means the complete story of how color perception works. However, we will use the theory to explain how the mixing of different light colors is achieved. While color perception science is in fact far more complex than what is presented here, this will serve as an introduction to the principles used in achieving a relatively complete spectral range of color using 3 primary colors in the case of projected images and television screens. In mixing colored light, I begin with a dark screen onto which I have projected the white text you see and left the rest of the screen blank. The 3 primary light colors or primary additive colors are red, green, and blue. Red stimulates the retinal cells in the eye that we call the red receptors or red cones. Green stimulates the retinal cells in the eye that we call the green receptors or green cones. Blue light stimulates the retinal cells in the eye that we call the blue receptors or blue cones. When the red and blue cones are both stimulated, we see magenta. Red light plus blue light produces magenta light. Magenta is a secondary additive color. When the red and the green cones are both stimulated, we see yellow. Red light plus green light produces yellow light. Yellow is a secondary additive color. When the blue and the green cones are both stimulated, we see cyan. Blue light plus green light produces cyan light, and cyan is a secondary additive color. Here I have the 3 primary colors projected with secondary colors appearing where any 2 colors overlap. But now for the first time we see the black screen has become white where all 3 of the primary light colors are projected. Primary red plus primary green plus primary blue add up to white light. Now we have seen the primary and secondary colors of light. I want to take a brief look at complementary colors. In the RGB color system, RGB color is another way of referring to additive color. The complementary colors to any of the primaries is a secondary color. When I add together complementary colors, I get white. Here, the red has a complementary color cyan. When you add those 2 together, you get white. When you add blue light and its complementary yellow light, you get white. When you add green light to its complementary magenta light, you get white. As an experiment, I want you to fix your eyes on the black spot in the middle of the white space for 30 seconds, starting now. I will let you know when the time is up. Resist the temptation to look around and try to keep the dot focused. If you go cross-eyed, bring your focus back to the dot. You should notice things happening around the rims of the colors, but keep focused on the black dot. What is happening is that the green cones are tiring in the area where green is falling on your retina, and the same thing is happening to the areas where blue cones are being stimulated and where red cones are being stimulated. When the screen changes to white, keep staring at the same spot. What you are now seeing is the complementary colors of the ones you have been staring at.